Hello everyone, my name is Niranjan Chaudhary. Today I am going to give presentation on compaction in geotechnical engineering under the guidance of Professor S.K. More sir. So first of all, we have to know about the introduction of compaction. So compaction of soil is the process of increasing unit weight of soil by forcing the soil solid into dense state by removal of air voids. So we have to know about the difference between consolidation and compaction. Compaction means reduction of air voids and consolidation means reduction of water from saturated soil due to long-term loading, and its main purpose is to improve soil mechanical behavior for construction. So second point is objective of soil compaction. What is the main objective of this point? So first one is increase shear strength, reduces the chance of slope failure or bearing failure. Second is reduce compressibility. In this, we have to minimize future settlement. And third is increase bearing capacity. It support heavier structure. And fourth one is reduce permeability. It slow down water flow, important for dam cores or landfills. And fifth one is minimize erosion and shrinkage. And third point is theory of compaction. What does it mean? So compaction rearranges soil particle to occupy less space, denser configuration. It reduces void ratio and air content, not water. And the process depends on type of soil. First is moisture content, second is compactive effort. And what is the goal? The goal is to achieve maximum dry density at an optimum moisture content. So here is the drawing for figure for before compaction and after compaction. And fourth is to what test. We have to read two type of test. One is standard Proctor test and modify Proctor test. So first one is here. So a lab test that determine the relationship between moisture content and dry density conducted by compacting soil in mold using. So we have to use, there is 2.5 kg hammer which is dropped from 30 centimeter in a layer, each given 25 blow, resulting data plotted as dry density versus moisture content. Its main purpose is to find OMC and maximum dry density, optimum moisture content and maximum dry density. So here is the figure, required figure for this part. And second test is modify Proctor test. It is similar to standard Proctor test but simulate heavier field compaction, and its usage is 4.5 kg hammer dropped from 45 centimeter compacted in 5 layer, and this result in high dry density, lower OMC, used for airfield, highways and industrial foundation. And next point is optimum moisture content. So optimum moisture content is the moisture content at which soil reaches maximum dry density during compaction, and it's why it is too dry that particles don't slide easily, and it is too wet water fills space, reducing dry density, and achieving OMC gives the most effective compaction. So here is the required graph for this point. And the next point is, what are the factors affecting compaction on soil? So there are several factors influences compaction effectiveness. Soil type like sand, it is easier to compact, like clay, sensitive to water content and moisture content, must be near OMC. Or compactive effort, higher energy is higher density, layer thickness, thinner layer is equal to better results. What is type of equipment? Different machine for different soil type is used. And next part is field compaction method. So common field method includes like rolling, smooth wheel, granular soil, sheep foot, clays, pneumatic tires like mixed soil, framing, manual or machine impact, vibrating, effective for sands, kneading, excusing shear for cohesive soils. And what are the compaction of different soil? So here is the figure for this. And for granular soil there is sand, gravels, and in this best compacted with vibration, less sensitive to moisture. And cohesive soil or clay need kneading or pressure, very sensitive to moisture content. This is the point for this part. And what are the effect of overcompaction and undercompaction? This point is also important. And overcompaction, it can break down particles and may reduce strength, especially in sands. Undercompaction, so it leads to excessive settlement. And second is poor strength and water seepage. So proper balance is main key in here. So last point is for conclusion. What is the conclusion of this topic? So compaction is essential for safe and efficient construction. So achieving the right OMC, optimum moisture content, and dry density improve soil performance. So use lab test, proctor, field methods, and equipment appropriate for each soil type. Proper compaction is equal to long lasting and safe geotechnical structure. So this is the conclusion and last topic is. So thank you everyone for watching my video. Thank you.